The first 12 problems in 6.5 are just a review, and they say to evaluate the logarithm or evaluate the expression without your calculator. Quite honestly, if you can't do these easily in your head, then I would use your calculator. So if I was going to do problem 2, the calculator way to do it would just be to pull out my calculator and do the log of 9 squared divided by the log of 3. And if this is what you need to do because you can't do exponents or logarithms well enough in your head, I don't care. So on my calculator for number 2, I do the log of 9 up arrow 2 for 9 squared divided by the log of 3. And it would give me an answer. So real quickly I could do that. Just go the log of 9. I think I could just hit the squared key. So 9 squared divided by the log of 3. And that tells me that this answer is equal to 4. If this was a test question and all you wrote down is the answer is 4, it didn't show any work, didn't tell me that you used your calculator, that's fine. If I was doing question 2 and I wanted to do it by hand, the question that this logarithm is asking is the base 3 to what power equals the argument 9 squared. In that form I don't know the answer, but I do know the answer to this question, 3 to what power is 81. The answer to this question is 4 because 3 to the 4th power is 81, and this is why the answer to problem 2 is 4. So if you do logarithms or exponents well in your head, do all these in your head. If not, use your calculator. I'll do them all by both ways, and you can pick the way that's easiest for you. Problem 4 is asking the question, the base 7 to what power is the argument 1? And I know that any number to the 0 power is 1, so the answer to that question mark is 0. The answer to this is going to be 0. The log base 7 of 1 is 0. If you want to do this on your calculator, you would just go log of 1 divided by log of 7. You'd hit enter and it's going to give you the answer. So ultimately, all I need to see is the answer. I don't need to see any work. So either do it in your head or use your calculator. Don't write anything down for logarithms. For instance, if I was doing problem 6, I would just write down 3 and I would be done. Because in my head, I realize that this asks the question, 6 to what power is 216? And I know in my head that 6 to the 3rd power is 216. So this is what I think, but I don't write. This is what I write. I just write the answer. If you can't do that thought process in your head, then just break out your calculator. Here I do log of 216 divided by the log of 6, and I get an answer of 3. Ultimately, for every time you're asked to evaluate a logarithm, you should just write the answer down and don't write your thought process or what you enter on your calculator. Should be able to do 5 and 7. When I go to 8, I could do 8 on my calculator. I'll show you that in a second. For 8, if I'm doing this by hand, this is what I'm thinking. I'm thinking ln is the same as log base e. So I think that this problem really is asking the question, the base e to what power is e to the 4th? And I know that e to the 4th power is equal to e to the 4th. So the answer to this is 4. My calculator works so nicely with ln's. To do this on my calculator, I would hit the ln key, and then second and the ln key to get an e with an exponent. I'll type the number 4 and close the 2 left parentheses, and my calculator will come back with the answer of 4 just fine. For number 10, I think this ln of 1 is the same thing as the log base e of 1, because ln and log base e are the same. This is asking the question, the base e to what power is the argument 1? I know that even e to the 0 power is 1, so that this answer is going to be 0. On my calculator, to do this, I would just type the ln and type in 1, and then hit enter and get that 0. For number 12, this is asking 5 to what power is 25 squared? Of course, you know that that's equal to 4. If you don't know that, or you have to do any work to get that, then you should just do log of 25 squared divided by the log of 5. I don't want you to spend any time thinking about logarithms. If you can't just look at the logarithm and know what it equals to, then just break out your calculator. There's no reason to do these by hand because it's going to take more time than you care to. The rest of the problems in this part of the video involve using 3 more rules of logarithm. These are the big rules of logarithms that we're going to need for the rest of the section. The rules of logarithms that I need for the rest of the section, I give them names. The first one I'm going to call the multiply to add rule. And the multiply to add rule says that if in one logarithm, any base, we have a multiplication, just had a phone call, so let me get back to this rule. So there's 3 rules of logarithms. The first is the multiply to add rule. The multiply to add rule says that if inside a logarithm you have multiplication, here's x times y, that I can change the multiplication into addition by creating one logarithm for each of the factors. So what was being multiplied inside my logarithm was x times y. I can, using the multiply to add rule, create one logarithm with an x followed by one logarithm with a y as long as they're joined with a plus sign. Let me show you real quickly, or maybe not so quickly, what I mean. So here's an example of this rule that I can do on my calculator. If I had the log base 2 of 16 times 32, in this case the x is 16, the y is 32, the items that are being multiplied are 16 times 32. If in a multiplication I have logarithms that have arguments that are, if inside a logarithm I have multiplication, I can separate each of the factors, in this case 16 being the first factor and 32 being the second factor, into their own logarithm as long as I keep the base the same. So the log base 2 of 16 times 32 is equal to the log base 2 of 16 plus the log base 2 of 32. This is what this rule tells me I can do. Let me show you this. I'm going to do the left side on my calculator, then the right side on my calculator. For the left side, I would do on my calculator, I do the log of 16 times 32 divided by the log of 2. So the left side on my calculator, if I did the log of 16 times 32 divided by the log of 2, it comes out to be 9. The right side better equal to 9 as well. The right side's a little bit harder. I need to do this logarithm and that logarithm separately and separate them with a plus sign. For this side on my calculator, I'll do the log of 16 divided by the log of 2 for this log, and then I'll type a plus sign, and then I'll do the log of 32 divided by the log of 2 for that logarithm. So to get this side entered, so there's more logarithms, it's more complicated. For this side, I do the log of 16, close out my parentheses, divided by the log of 2, that's that one. Follow up with a plus sign, and then for this one, log of 32 divided by the log of 2, and it gives me 9 as well. So this rule tells me that if inside a logarithm I have multiplication, that I can expand one logarithm into multiple logarithms. Let me do another example of this rule that's a little more complicated. This rule actually extends even if you have just more than 2 things being multiplied. Let me do the log base 3 of 3 times 9 times 81. There's 3 factors in this logarithm. The multiply to add rule says if I have one logarithm that has multiplication, that I could expand it into as many logarithms as terms that are being multiplied, as long as I make each factor in its own logarithm And I separate the logarithms with plus signs. The first logarithm is going to be the log base 3 of 3. The second logarithm after the plus sign is going to be the log base 3 of 9. And the last logarithm is going to be the log base 3 of 81, again followed by a plus sign. I can show you that this extension of the multiply to add rule works on my calculator. Let me do this left logarithm first. The left logarithm is going to be the log of 3 times 9 times 81 divided by the log of 3. And that gives me 7. For the right-hand side, it's a mess. I'm not going to write down what I'm going to enter. I'm just going to enter it. First, I'm going to enter this logarithm, which is going to be the log of 3 divided by the log of 3. Did that logarithm. Now I'm going to do this plus sign. This logarithm is going to be the log of 9 divided by the log of 3. And then followed by this plus sign. This logarithm is going to be the logarithm of 81 divided by the log of 3. And this whole right side comes out to be 7. So the multiply to add rule basically says you could expand from one logarithm into several logarithms separated by plus signs. If there's multiplication inside a logarithm, then each of the factors or each of the numbers that's being multiplied can go in their own logarithm with that base that the problem has separated by plus signs. That's the first of 3 rules that we need to learn. The second of 3 rules is the divide to subtract rule. And the divide to subtract rule says that if you have a single logarithm that has a fraction or a division, you could expand that logarithm into 2 logarithms. If you put the if you make a logarithm that first has a logarithm of the numerator followed by the logarithm of the denominator with the base that the problem has separated by a minus sign. Let me show you an example of this real quickly. This rule would say that if I had something like this, the log base 5 of the fraction 625 over 125. This rule says in a logarithm, if I have a division, I can make one logarithm and expand it into 2 logarithms. I would expand it into 2 logarithms by forming 2 logarithms separated by a minus sign. And the base of those logarithms is the base of the problem. The first logarithm is going to have an argument of the numerator. In this case, it's 625. The second logarithm is going to have the argument of the denominator. In this case, it's 125. I claim that this side is equal to that side, and let me show you on my calculator really quickly that these 2 sides are the same. So on the left-hand side, I would do on my calculator the log of 625 divided by 125 divided by the log of 5. And the left-hand side comes out to be 1. On the right-hand side, I'd enter the first logarithm, which is a log of 625 divided by the log of 5. And then I'd enter the minus sign. And then for this logarithm, I do the log of 125 divided by the log of 5. And I'd get 1 as well. Turns out that we could use these rules in conjunction with each other. We can do a blending of the multiply to add rule and the divide to subtract rule. And I'm going to do that with 2 separate examples, and I'll show you exactly how these will work. So I'm going to try to expand these and to show you how to use the rules kind of in tandem. So these rules, the first 2 rules that we just learned, the multiply to add and the divide to subtract rule, can be used together, and it's a little bit tricky to use them together. So let me make up a problem and show you how to use those 2 rules together. So here's a logarithm that has both multiplication and division. Let me figure out what this equals pretty quickly on my calculator. Easy enough to do this on my calculator. On my calculator, I do the log of 4 times 64 divided by 16 divided by the log of 2. This whole logarithm is equal to 4. If it wasn't clear, what I entered here, I entered the log and I did 4 times 64 divided by 16 for what's inside the parentheses, closed it out, and then divided by the log of the base. And that's equal to 4. When I go to expand this into multiple logs, I can expand this into 3 logs because there's kind of 3 different numbers here. So I'm going to expand this into 3 logs as opposed to just 2 logs because there's 3 numbers. Each of the logs has to have a base of 2 because the original problem has a base of 2. So I need a log base 2 for the number 4, a log base 2 for the number 64, and the log base 2 for the number 16. When I go to put signs between these, the only signs that I'm allowed when I expand using my rules are plus or minus. And it's real easy to know whether I get a plus or a minus sign between the logarithms. I get a plus sign if the number's in a numerator. I get a minus sign in front of the log if the number's in the denominator. So when I go to expand this, because the 64 is in the numerator, it's going to get a plus sign. When I go to expand this, the 16 is going to get a minus sign because it's in the denominator. When I do this on my calculator, this should come out to be 4. And let me show you that it does equal to 4. Real quickly, I'm going to do this on my calculator with 3 logarithms. The first log I'm going to do is the log of 4 divided by the log of 2. Got that entered. Now I'm going to tag on this plus sign. Next log is going to be the log of 64 divided by the log of 2. Then I'm going to put this minus sign. The last log is going to be the log of 16 divided by the log of 2. And if I did this right, because the original logarithm's equal to 4, and I say this is an expansion, the correct expansion of the original logarithm from 1 log to 3 logs, when I hit enter I should get 4, which I do. So if I was asked to expand the original problem that I wrote, the log base 2 of 4 times 64 over 16, it expands into the log base 2 of 4 plus the log base 2 of 64 minus the log base 2 of 16. Let me write just a slight variation of this problem and show you how it expands differently. So I'll make the same numbers, log base 2. Now I'm going to write of, how about 4 divided by 64 times 16. Let me figure out what this equals on my calculator. It's a little bit trickier on my calculator because that denominator has 2 terms. On my calculator, the denominator is going to have to go in its own parentheses. So to figure out what this equals to, I'd have to go the log of 4, then divided by, and then the denominator 64 times 16 is going to need to be in a parentheses, and then the whole logarithm has to have a parentheses. So I get a denominator and the logarithm in parentheses. So 2 sets of parentheses, and then divided by the log of 2. So this on my calculator, I would enter like that as 1 logarithm. So I could do this as log of parentheses 4 divided by parentheses 64 times 16. Close out the parentheses for the 64 times 16, close out the parentheses for the log, and then divided by log of 2. I didn't do something right. Log of 4 times 64 times 16 divided by the, oh, I didn't, enter this right. Let me try this again. The log of 4 divided by parentheses 64 times 16. Close out my parentheses, close out my parentheses. That's this one entered. Now divided by, and then log of 2. Close out my parentheses, hit enter, and get negative 8. I knew the answer in my head, so I don't know what I entered wrong, but I must have been a parentheses that I didn't put in properly. So now I'm going to expand this into 3 logs. And how would I expand the log base 2 of 4 over 64 times 16 from 1 logarithm into 3 logarithms? Super easy. I make 1 logarithm for each of the numbers. So I make a log base 2 of 4 a log base 2 of 64, and a log base 2 of 16, because those are the three numbers that are either being multiplied or divided. What signs go between the logarithms? The only signs that are allowed between the logarithms are pluses and minus. You get a plus if a number's in the numerator, a minus if a number's in the denominator. Both the 64 and the 16 are in the denominator, so preceding those logarithms, I get minuses. I claim that these three, if I do these on my calculator, are going to give me the same -8, and let me show you that that actually works. So I'm going to do the log of 4 divided by the log of 2 minus the log of 64 divided by the log of 2 minus the log of 16 divided by the log of 2. When I hit enter, I cross my fingers that I get -8, which I do. So I've correctly expanded from one log into three logs using kind of a blending of the multiply to add rule and the divide to subtract rule. If a problem has more than two numbers and is a combination of multiplication and division, you're going to need to know the proper signs. If a problem only has multiplication, you don't have to worry about multiple rules. You're just going to use this rule. But if it has both multiplication and division, then we'll start worrying about using the rules together. One last rule that we have to deal with, and that's kind of the exponent to multiply rule. And it's an easy rule. The exponent to multiply rule says something like this. It says the log base b of x to the n power equals to n times the log base b of x. Says if inside a logarithm there's an exponent in front of a letter, you can drag that exponent out and make it a coefficient. Let me show you real quickly an example of that rule. So here's an example of the exponent to multiply rule. What it says, the exponent to multiply rule says that if I have one logarithm with an exponent, that I can take that exponent and drag it in front of the logarithm and leave everything else the same. That rule says that these two logarithms are equal to each other, because in this case the n is 4 and the x is 9. So if you have an exponent that's an exponent to an argument, you could drag that out front. Let me show you that both of these equal to each other. So on my calculator, the left-hand side is the log of 9 up arrow 4 divided by the log of 3. The left-hand side is going to be 8. The right-hand side, to do it on my calculator, I do 4 and then log of 9 divided by log of 3, and it also equals to 8. To use all three rules together, the instructions would look something like this. If I gave you an instruction and I said expand into sums and or differences of logs, and express exponents as multiplication, multiplication, it would tell you to take the logarithm that you're given and expand it from one log to as many logs as you have letters. Let me do two examples of this. About the log base 4 of 64 times 256 cubed. If I want to expand this into logarithms, I'm going to expand it into two logarithms because there's two numbers being multiplied, 64 and 256 cubed. To expand this into multiple logs, I need one logarithm, base 4 for the 64. I need a second logarithm, base 4 for the 256 cubed. I have to decide whether I put a plus or minus sign between the logs, and this one doesn't have a division, so it's just using the multiply to add rule. The sign that's going to go between these is a plus. So I've expanded into sums and differences of logs. I expanded this into a sum of logs, And now I need to express exponents as multiplication. I don't know why I didn't write all that there. But to express exponents as multiplication means to use the last rule and make the exponent a multiplication. The expansion of this problem that would be correct would be the log base 4 of 64 plus 3 times the log base 4 of 256. Let me do the original problem on my calculator and this problem on my calculator and show you that they're equal to each other. So the original problem on my calculator, I do the log of 64 times 256 up arrow 3 divided by the log of 4, and the original problem is equal to 15. My rewrite of the problem, expanding it, I do the log on my calculator of 64 divided by the log of 4, close out the parentheses there, and then here I'd go plus 3 times the log of 256 divided by the log of 4. And if I did it right, this whole thing comes out to 15. If I did it wrong, then I don't know what I did wrong there. Oh, I forgot the divide sign between the 64 and the 4. Let me redo this one. This one has to be the log of 64 divided by the log of 4 plus 3 times the log of 256 divided by the log of 4. And this whole thing comes out to 15. So I've used the rules properly. I expanded into sums of logs. I didn't get differences because there wasn't a minus. And I made the exponents in the multiplication. Let me do one more of these, and then we'll get into the regular problems. So same instructions. Let me work with this log. The log base 3 of 9 squared times 81 over 27 to the 5th. Let me figure out how to expand that. Well, I'm going to expand that into 3 logs. So the first thing I'm going to do is I'm going to expand into 3 logs, and one logarithm is going to have a 9 squared as its argument, because that's one of the 3 numbers. Another logarithm is going to have 81 as its argument, because that's the second number that I see. And the third log is going to have a 27 to the 5th as its argument, because that's the third number that I see. Now I need to put signs between the logarithms. When I expand, I only ever put pluses or minus signs. Numbers that are in the numerator get plus signs. Numbers that are in the denominators get the minus sign. So I expanded this into 3 logs, and now I'm going to express the exponent as multiplication. I'm going to rewrite the first log as 2 times the log base 3 of 9. The second log I'm going to leave at the log base 3 of 81. And the third log I'm going to write 5 times the log base 3 of 27. I claim that both of these are equal to each other. Let me do them both on my calculator to show you that they're equal. This one should be the easier one. For this one, I'd go log of 9 squared times 81 divided by 27 to the 5th divided by the log of 3. This whole logarithm comes out to be minus 7. The expansion of this also has to equal minus 7. To do the expansion, I'd go 2 and then log of 9 divided by log of 3, and then plus, and then log of 81 divided by log of 3, and then minus 5, and then log of 27 divided by log of 3. When I hit enter, I get the same minus 7, so I've correctly expanded. This is what the homework's going to be that we need to come up with now. So for problems 13 through 24, we need to expand from one logarithm into sums and differences of logs and express any exponents of multiplication. The problems in the homework I can't check on my calculator because it has letters. So I'm going to do number 14 first. 14, I'm going to expand into 3 logs because there's 3 letters. So when I go to expand number 14, I'm going to make a log base 4 for the x. I'm going to make a log base 4 for the y cubed, and a log base 4 for the z to the 5th. I have to put signs between the logarithms, and the only signs that I'm allowed to put in are plus or minus. The only time I get a minus is if a letter's in a denominator. Since there isn't a fraction, there's no minus signs. Now, I'm going to make the exponents into multiplication and get my answer for problem 14. My answer to number 14 is going to be the log base 4 of x plus 3 times the log base 4 of y plus 5 times the log base 4 of z, making the exponents into multiplications. I don't really need the parentheses around the x, the y, and the z, but it's kind of nice to have them. Your problem 13 should work similarly, but you only get 2 logarithms because you only have 2 letters. You're going to start off, you're going to expand it, you're going to get the log base 3 of x squared plus the log base 3 of y cubed. You expand it into 2 logarithms. You don't get minuses because there isn't a fraction. The only signs you're allowed to put between are pluses and minus. That's the expanding, and now you're going to express exponents of multiplication and get 2 times the log. I don't need this parentheses here. You get 2 times the log base 3 of x plus 3 times the log base 3 of y. Your 15 works just like my 14. My 16 is a little bit different. So for 16, I'm going to expand. It says there's only 2 letters. I'm going to expand into 2 logs. So I'm going to write 1 logarithm with the x to the 4th and a second logarithm with the letter of y. Because it's a division, any letter that's in the denominator, its logarithm gets a minus in front. So that's the expanding. Now, I'm going to make exponents into times, and I'll have my answer. So my answer is going to have 2 logarithms. The first logarithm is going to be 4 times the log base b of x, making the exponent into a times using that third rule. The last logarithm doesn't have an exponent, so it doesn't need to change. Your 15 doesn't work like that. Let me get on to the next page where we have a little more stuff to worry, a little more difficult stuff to worry about. I'll do both 18 and 19. You can work on 17. When I do 18, I'm going to expand it into 3 logs. So I'm going to write 1 logarithm, base 7 for the x, a second logarithm, base 7 for the y, and a third logarithm, base 7 for the z cubed. I need to put signs in front. The only signs I'm allowed are pluses and minus. The only times you get minus are when letters are in the denominator, so both the y and the z will get minuses. And now I'm going to make the exponents into multiplication and get my answer for problem 18. For problem 18, my answer is going to be the log base 7 of x minus the log base 7 of y minus, and then the exponent I'm going to make a multiplication, 3 times the log base 7 of z. If you were going to do number 19, you're going to make 4 logarithms, 1 logarithm base 2 for the x, a second logarithm base 2 for the y, a third logarithm base 2 for the w squared, and a fourth logarithm base 2 for the z to the 5th. Kind of wrote too big here. The logarithms I get minuses in front of them is the w and the z logarithm because they're in the denominator. If a letter's not in the denominator, it gets a plus in front of it. For my answer, that's the expanding of my logarithms. For my answer, I need to make the exponents into multiplication. The first logarithm, I'm going to leave the log base 2 of x. The second logarithm, I'm going to leave plus the log base 2 of y. And then for the third logarithm, I'm going to make it minus 2 log base 2 of w. And for the fourth logarithm, I'm going to bring the 5 out front and make it minus 5 log base 2 of z. So hopefully you can do 17. 20 and 21 are pretty straightforward. I'll do 20 and let you do 21. In 20, I'm going to expand this into 2 logarithms. They're both going to be base 3. The first one's going to have an x squared for its argument. The second one's going to have a y for its argument. The sign that goes between them is a plus because there's multiplication. So that's expanding from 1 log into 2 logs because there's 2 letters. And then for my answer, I need to make the exponents in the multiplication. So I'm going to write log base 2 times log base 3 of x for the first logarithm, and log base 3 of y for the second logarithm. Your 21 should work the same way. For 22, 23, and 24, we have to know that square roots, square roots are 1/2 powers. Can't even write right now. And cube roots are 1/3 powers. So in order to do problems 22, 23, 24, I need to get rid of the radical symbols. In problem 22, I see a square root of z, and in order to do this problem, I need to change it to z to the 1/2 power, because square roots are 1/2 powers. Now that I have it written without the radical, it's easier to do. I'm going to expand this into 2 logarithms. I'm going to make it the logarithm base 4 of y, plus sign because there's no subtraction, plus the logarithm base 4 of z to the 1/2. Not quite there for my answer because I haven't made the exponent into coefficient. My answer for number 22 is going to be the log base 4 of y plus, and then bring the 1/2 out and make it a multiplication, 1/2 times the log base 4 of z. I'll let you do 23 and I'll move on to 24. For 24, I have to change the square root of x to x to the 1/2 power, and the cube root of y to y to the 1/3 power. Now I can expand this into 2 logarithms. I'm going to get the log base 5 of x to the 1/2 minus, because of the division, log base 5 of y to the 1/3. That's expanding, and now I'm going to get my answer by making the exponents in the multiplication. My answer is going to be 1/2 times the log base 5 of x minus 1/3 times the log base 5 of y. Hopefully this is good. I've done like about 7 hours of videos today, and I feel like I'm starting to make mistakes. So give 23 a go, and we'll just keep trudging on.